Hi, it's Nicole the Math Lady. Today we're working on the area of a parallelogram. Now, you know in the past we have worked on the area of a rectangle. Do you remember what that formula was? Yeah, it was length times width. Well, here we have a parallelogram. You might also remember that a rectangle is a kind of parallelogram. Parallelogram just means it has two sets of parallel sides. A rectangle has that, but it has 90-degree angles, right? So if we decided to take a scissors and cut off this little triangle to make a 90-degree angle here, do you realize that we could take that triangle and flip it and slide it over and put it right here? And it would give us a rectangle. So here's the good news. The formula for the area of a parallelogram is related to that one for a rectangle. Where a rectangle is length times width, a parallelogram, the area is what's called base times height. So base is the same exact thing as what we would call the length, generally the length in a rectangle, but the height, normally we call that the width. I mean, usually it depends on what's longer, but the height has to do with the distance when you drop that 90 degrees. So this right here is called the height. You might be saying, Nicole, well, what's this called? Well, if it was a normal rectangle, right, we would have called this the length. We would have called this the width. So I'm going to write length here, width here. Because it's a parallelogram, we just use different terms. We use base for that piece that it's sitting on, but the height is the key here. It has to be that 90 degrees. And often with a parallelogram, you know, it's not a right angle because it would be a rectangle, right? So you will see that they will drop down these little dotted lines to show you, here's what the height would be if we dropped it a 90-degree angle here. And that's what you're going to use for your base times height formula. Let's try it with a few examples. If I asked you to find the area of this parallelogram, we would do, again, base times height. Our base is 5 inches. Our height, remember, it's when, I'm going to draw my little rectangle, that 90 degrees, so we're looking for that dotted line, it's going to be 3. 5 times 3 is 15 inches, and we still use that squared label because we're looking for area. Hi, it's Nicole the Math Lady. Today we're talking about the area of a trapezoid. Yep, not too bad. I think you're going to get this really quick. Let's take a look at this example. Here we have a trapezoid, and if you remember, a trapezoid is a polygon, right, 4-sided figure, but it only has one set of parallel sides. So here's a parallel side, one set there and there. Okay, now how do we find the area? Well, I want you to notice that a trapezoid can be divided into 2 triangles. Oh, that wasn't a very good straight line. Pretend it's straight. Now, what does that mean? It means we have a triangle here, and we have a triangle here. And what do we need of triangles to find their area? Well, the formula is 1/2 base times height. Okay, well, let's take a look. If we did this one first, we have a base. It's 7 inches. We also have a height. The height of this is going to be 4 inches. Well, how do I know that, Nicole? It's all the way over there. Watch, I can just slide that height over, and boom, it turns it into, you have to look at it from the side, but it turns it into a height for this triangle. So the height is still going to be 4 inches. So let's fill it in. 1/2 times the base, 7, times the height, 4. And now let's clean it up a little. 2 goes in here, 2 is left over, and we have 14 inches squared. Now that's just for the first triangle. We've got to do the second triangle, but the formula still applies. 1/2 base times height. Well, what do we have? We've got our 1/2. Our base this time is going to be this triangle up here. So our base is going to be 5. And what's our height? Guess what? It's still going to be the same height, but I'm just going to shift it over here so you can see it better. So let me erase this one. I'm going to shift this one Ding, 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 ding. So if you look at it from the side, you can see that the height is still 4 inches. So in both cases, the height's going to be 4, and we're just using the different, the height's going to be 4, and the base is going to be what that side is for the triangle. Here we go. Let's cancel here, and we have 10 inches squared. Add the two of them together. 14 plus 10 gives me 24 inches squared as my area. Take a look at this trapezoid. What are we going to do? The same thing. We're going to divide this into 2 triangles. And it doesn't matter, by the way, which diagonal you choose. You can do it this way or you can do it this way. It'll still give you 2 triangles with 2 different bases. Let's do it. So the first one's going to be 1/2 base times height. So let's do the side over here. 1/2, our base is going to be 6. And our height, here we have 4 centimeters. And I'm going to, since we're talking about this triangle, I'm just going to slide this over so you can see it better. Easier to see when I do it like that. So it's going to be 4 centimeters for the height. And let's just do some canceling here. 2, 3. Our answer is going to be 12 centimeters squared for that first triangle. Let's do the second triangle. We have 1/2. Our base is going to be a 3. And our height is still going to be a 4. But I'm just going to shift it over here so it's easy for you to see that it's the height of this triangle. So it's times 4. And let's do some canceling. We are left with 6 centimeters squared. So if we add them together, we get 12 plus 6, and our answer is 18 centimeters squared for our area of the trapezoid. That's simple. If you can divide them into 2 triangles, find the area of one, find the area of the other. You've got different bases, but you have the same height each time. It's not bad, huh? Pretty simple. Okay, try the practice problem so you make sure you've got it. So Nicole the Math Lady, I'll see you next time. Bye-bye.